Good afternoon, students, and today we will be discussing with our seventh practical, which is based on SVM. So today's class will not be discussing in detail about SVM because SVM has been already discussed. So what is SVM? Support Vector Machine. Okay, this is actually even in the previous experiment, that is experiment number 7, we were discussing about SVM, that is multi-class classifier, with the help of that was for binary class. What is the meaning of binary? Only two class classifications we have done it there. So the same example we have taken here in this case, multi-class, the meaning is more than two. So here as a beginner we are taking only three classes. If you want, you can take any other data set, okay, and you can go with more than two classes, okay, that is fine. This is not at all compulsory that you have to do with the same program. I'm just explaining one, and you can go with any type of database and data sets, and then you can go with SVM classifier. The only thing is that the concept should be applied, that's it. So three class classifier should be there. Here the example which I am plotting here is the same example as in previous, that is iris flower dataset. In iris flower dataset we are having iris flower of 3 category. Okay, this is a very common database which is readily available. It can be used, it's a freely available data sets, and considered as one of the very frequently used or most famous data set for classification. So here the iris flower is categorized into 3. Total we will be having, if you observe, this is 3 categories. One is setosa, another one is, you could see that iris versicolor, third one is virginica. Okay, so these are the 3 data set which is available. I'm showing you the same write-up which I have uploaded in the Google Drive. Okay, so you can see that. So in this data set, if you see closely, even for a human being, it is sometimes very difficult to identify these 3 classes for iris flowers. So the iris flower classification is based on the sepal length, the sepal width, petal length and petal width. So sepal length, sepal width and its width, petal length and its width. So based on these 4 features, okay, based on these 4 features, it is classified into whether setosa, versicolor or virginica. When you go through the data set of this, you can see that around 150 sets of data you can see. First 50 is based on setosa, next 51 to 100 is based on versicolor, and again maybe 100 to 150 is of virginica. So that equal number of data sets for all. So these are all the speciality for this kind of data set. Okay, so that's why we are using the same thing. See, in the higher version there is readily available functions are there. Here we are using some or readily available examples are there. I am using here, that's why those are using this, that is 2015A onwards, they can even go with this. Okay, whatever the way I am explaining, there are 2 ways, 2 or 3 ways you could do it. So all are welcome, any way you do it, no problem, only the concept of SVM should be there. Okay, so the compact class classification, ECOC class, that is compact multi-class model for support vector machines or other classifiers that we will be using here. The description for that is, I hope it is visible properly. I'm trying to enlarge it so that you will be able to see properly. The compact classification, ECOC, is a compact error correcting output codes. That's why the name ECOC. E stands for error, C stands for correcting, O stands for output codes. ECOC, output codes for multi-class model, that is available. So the compact classifier does not include the data used for training the ECOC multi-class model. Therefore you cannot perform the tasks such as cross validation using the compact classifier. So what you can do is directly use a compact ECOC multi-class model for labeling new data and then predicting accordingly. So how we can construct that? This portion is actually available even in the help file. Okay, so compact MDL, that is compact MDL will be returning a compact ECOC multi-class that is compact SVM model from a full trained ECOC multi-class model, and this train an ECOC classifier using different learners and the one versus all coding design. So what we are using here is Fisher's data, Fisher's iris data set especially. X is the means, this one stands, X stands for the measures and Y stands for the species. Okay, so I hope you will understand the meaning of it. So the which is the species, whether it is setosa, whether it is versicolor, or whether it is virginica. And K will be there. What is K? Is the total number of classes. So here in this case we are having 3 classes: setosa, versicolor, or virginica. So it will be based on that. See, all the theory part also I have added here. You can go through it if you want. Then the algorithm is first loading the iris data set for multi-class data. Sorry. Typically we will be iris flower class 3 data set we will be using. Remove the empty classes, then we will be displaying the class names which are the unique class in the data set, and K is the total number of classes. Here the K will be 3. Multi-class means minimum 3, more than 2. Okay, it will be minimum 3 in that case. For reproducibility, seeds the random number generator using non-negative integer seed, so that the random or random I or random n can produce a predictable sequence of numbers. For one versus all coding, we should design, there are K equal to 3 binary learners. Specify the templates for binary learners, such as will be having binary learner 1 and 2 for Navier-Bayes classifier. By default, each predictor is conditionally and normally distributed given its label. Now we can even go for this one, that is binary learner 3 is an SVM classifier. We have to specify this 3 classifier to specify the Gaussian kernel. Which kernel we will be using is Gaussian kernel. Okay, so for that we will be using T learners. See here, to reduce the size of the code or length of the code, we are using some what we could say the inbuilt functions, okay, which is available. That is T learners can be used where TNB, TSVM will be there. What is this TNB stands for, that we will discuss, and TSVM are template objects for Navier-Bayes and SVM learning respectively. So NB is for Navier-Bayes and for SVM is for support vector machines templates. Okay, so we will be using the T learners for that, temporary learners for that. Then we will be fitting the multi-class model for support vector machine, or it can be even used for other classifiers using CVM DL. What is that? CVM DL is a classification partition for ECOC. What is ECOC? Error correcting output codes. For cross validated model. What is this cross validation? Is nothing but we are going for checking the error. Okay. Now in the next step, what we are doing, inspect one of the trained fold, such as using dot notation such as CVMDL trained. This one directly is available. This program you can even take it from the help file. Okay, each fold is a compact classification ECOC model that is trained for 90% of the data. So the same thing, display the trained SVM classifier, the third binary learner from this 1, 2, 3. So third binary learner in the first fold. Then you can even estimate the error, how it is exactly getting trained. Okay, so this is what we are using it here. The same thing we are applying here. So which model we will be applying is ECOC model. Okay, and first we will be loading the data from Fisher's, which is Fisher iris data set, and we can directly get, you can see that, I'll just show you. You can remove the empty classes first, then k we can set it as the number of classes. What are the classes? Setosa, versicolor, virginica. Hope you know that very less number of codes, everything, since we have used most of the ready-made functions. What I have written is the commenting line. I suggest that all of you should write whatever the program you write, you have to use the commenting lines, because some more easiest way also you can use it, because some of the ready-made functions are available in the latest version. Okay, so you can use it, because we have 2021 available, so that also you can use it. So the SVM multi-class classification readily available in the help file, that also you can use, no problem. So those are having issues, I thought I'll just discuss with the older version even. Okay, so we will be using for reproducibility, RNG is control random number generation. So we will be using this for random number generation seeding. We will be using RNG seed or RNG1, and for each and every class, so TBN we are training for the template for Navy's base, and TV SVM is for template for SVM. So in SVM I can either use kernel function as Gaussian or RBF. Okay, here whichever I am using is Gaussian, both are okay. So in which you can see that the SVM model, it will be fitting ECOC model. Okay, fit ECOC model. What we are doing? Fit multi-class model for support vector machines. The meaning of this is we are training. We are doing the training for it. So CVMD model training. So once we do this, you can get the training as in this way. Okay, that is predicted class names. What are the features which is having? X1, X2, X3, X4, and the response name as in Y. What are the classes it is having is Setosa, versicolor, and virginica. That is 3 class classifiers. We will be using binary classifier out of the 3 by 1 cell, means we will be using this classifier. Okay, this one. This is binary class 3. Is a SVM classifier. You can say that specifying to use Gaussian kernel. So here it will be, they will be specifying that in this you have to use Gaussian kernel for training. So this is the coding matrix, we are using 3 by 3, and once we train it using this binary learner 3. What is binary learner 3? Is SVM. If you observe that, you can see that this is SVM. Kernel which we are using is Gaussian. Then you can get the output. One second. Very less number of codes. If you directly see this, there is nothing, but I have just added with all the commands so that you will understand. So there are 3 classes which we are planning to use, which is Setosa, versicolor, and virginica, and the total number of classes is 3. So it is a multi-class SVM model. Now what are the features which we are using is X1, X2, X3, X4. Why these are the features which we are saying? One more thing I would like to say. I will just take the experiment, then you will understand it better maybe. So here you could see that, yeah. So sepal length, sepal width. So X1, X2, X3, X4. And what is Y? Y is species. Species can be either Setosa or versicolor or virginica. So only one output. Okay, so it is 4 features. For these 4 features we will be getting one output. Okay, and what is the output? It can be either Setosa or versicolor or virginica, depends upon our classes. Okay, like this way it is classifying, and again it is saying that there is less number of errors. The generated error in terms of performance we can calculate it as 0.03. Okay, this is how you can perform this. There are different varieties you could perform the SVM classification. SVM stands for support vector machine. So why we are going for this support vector machine, that we have already discussed in the class a lot. So if anybody is having any issues or not understanding or anything, please let me know. Otherwise, it's very simple way I have tried to incorporated this with the help of functions. Okay, one more thing, yeah, if you use this kind of ECOC or maybe SPM training or any functions, if you want, you can even search it and you can find it accordingly. That is also fine. Anybody is having any doubt regarding this? Okay, so support vector machines, you can do it with different varieties. One among them is using the template SVM. So what you have to study is what is this template SVM, how it is working, what is fit ECOC. So why specify the T as a binary learner, or in a set of binary learners you can say that fit ECOC function. So with the help of this we are getting the training. So this is the easiest way you can represent an SVM using support vector machine template that is readily available. So I have used it. This is because many of them will be having a confusion that whether this will work with the older version. That's why I thought I will just check with the older version. So it's working with older version. The latest versions 2021 we have different varieties of the same algorithm with different data types. That also you can go with. Any way you do, that is fine. What is important here is you should know how exactly you are able to you should know exactly how you are able to get the output. It should be able to classify the output. So for easy classification, what I have done is I have used the ready-made functions. Either you can use the ready-made functions and do this, or whichever way. Okay, because this is 3 class classifications I have taken. So I will come up with some more examples maybe in the coming classes, with even with Python. Okay, we will try that. But what I suggest is, since for your oral and everything we will be focusing the all 8 programs in first we will be focusing on MATLAB itself. Since we have campus wide license, we can justify for it. And Python, those who are interested, I know that some of the students are interested even with Python, and it may give you more weightage to your syllabus, that if you have done with Python, so that discussion also can be done. Anything you would like to say or add or ask questions? You're always welcome.